If you follow any piping system in your plant, you'll come across a lot of different components. Some, like this strainer, you're pretty familiar with. You're often called on to clean or replace strainers and filters. But other components, like pipe hangers, you may not be so familiar with. You see them often enough, but you probably don't know how they work. Pipe hangers are so reliable that they may go for years before they require any attention. But if they do break, your lack of experience in working on them could put you at a real disadvantage in trying to fix them. So in this unit, we'll be discussing a number of common piping components, or piping auxiliaries as they're often called. For each one, we'll explain what its job is, how it accomplishes that job, and we'll point out some routine maintenance that should be performed. Now we'll start with filters and strainers, piping auxiliaries that require quite a bit of maintenance. Then we'll move on to components that don't require as much maintenance, pipe hangers, expansion joints, and surge dampeners. Now this pipe carries water. Over a period of time, the water will cause corrosion on the inside surface of the pipe. This corrosion can cause a lot of problems. To see why, let's look inside the pipe. As the inside wall corrodes, some corrosion products break loose and are carried along by the fluid inside the pipe. If these particles lodge in some critical area, like this valve seat, the valve will not be able to close fully, and some fluid will leak by. Some sort of component is necessary to trap these corrosion products and any other particles in piping systems. There are two similar components that accomplish this job, filters and strainers. Filters typically use a cloth or heavy paper screen to trap contaminants, while strainers usually have a metallic screen. Another difference between filters and strainers is that filter elements are usually layered, while strainers generally have just one surface for fluid to pass through. Here's a representation of a typical strainer screen. You can see that it has just one layer with uniform openings in it. This is known as a surface medium. As fluid passes through a surface medium, particles too large to fit through the openings are trapped in the screen. A typical filter element, on the other hand, has several layers with progressively smaller openings in each one. This is known as a depth medium. As fluid passes through a depth medium, particles are trapped in each layer. In most cases, filter elements can remove smaller particles than strainers can. Now, these distinctions between filters and strainers are good in general, but there are exceptions. Some strainers, for example, do have depth mediums and can remove smaller particles than many filters. And you'll find some filters that do have metallic filter elements. Some filters may even use sand as a filtering medium. So, as we go along, keep in mind that the terms filter and strainer are not clear-cut categories. They're used almost interchangeably. Now, this is a typical Y-type strainer. It's commonly found in steam systems. In this cutaway, you can see the strainer element here. Steam enters through the inlet here. It passes through the strainer and is discharged here. But the strainer has another outlet here. It allows the strainer to be blown down and cleaned of any particles that have collected inside. Here you can see a Y-type strainer installed in a steam line. The blowdown line is here. There's also a blowdown valve. Opening the valve cleans out the strainer. Now here's a filter you're probably familiar with. It's an oil filter from a car engine. In this cutaway, you can see the filter element here. Oil enters through these small holes. It flows across the top of the filter element and then through the heavy paper filter. Finally, the filtered oil leaves through this large hole in the center. Let's look at a typical system where this oil filter might be installed. And keep in mind that what we say about this filter also applies to strainers. Okay, here's the oil reservoir. A pump moves the oil from the reservoir to the equipment being lubricated. The oil returns to the sump through this line. The filter, or strainer, is here. On one side is an inlet line, and on the other side is the outlet line. Finally, there's a gauge to measure the pressure drop across the filter. Now, this is known as a full flow filter arrangement. All the oil that's pumped from the reservoir passes through the filter. But a system like this requires some way to ensure that oil will continue to reach the equipment, even if the filter gets clogged. Otherwise, the equipment could burn up. To make sure that oil continues to flow, there may be a relief line around a full flow filter. If the filter becomes clogged, the relief valve will open, allowing the oil to go around rather than through the filter. In some cases, full flow filters have a built-in relief valve. In this filter, it's nothing more than a small disc held down by a spring. If the filter becomes clogged, pressure will build up inside the casing, causing the spring-loaded valve to lift, discharging the oil directly to the filter outlet. Another filter arrangement is the bypass filter system, or partial flow system, as it is sometimes called. It's designed so that only part of the flow goes through the filter. The rest of the flow goes through the bypass line. This bypass line usually has an orifice to balance flow between the bypass line and the filter. The drawback to this arrangement is that since not all the oil goes through the filter, fewer contaminants will be filtered out.